Frank Adams was a manufacturer of electrical bus duct and other electrical equipment. The company was founded in 1956 and was headquartered in St. Louis, Missouri. Frank Adams was acquired by Eaton Corporation in 1985. Frank Adams products are no longer manufactured or sold by Eaton Corporation. However, some of their products may still be available through surplus or used equipment dealers. Frank Adams bus duct was known for its high quality and reliability. The bus duct was constructed of heavy-duty aluminum and was designed to withstand the rigors of industrial environments. Frank Adams bus duct was available in a variety of sizes and configurations to meet the needs of different applications. It is possible to find Frank Adams bus duct for sale through surplus or used equipment dealers. However, it is important to note that these products are no longer manufactured and may not be readily available. It is also important to carefully inspect any used bus duct before purchasing it to ensure that it is in good condition and suitable for the application. If unable to find Frank Adams bus duct, there are a number of other manufacturers who produce high-quality bus duct products. Firstly, ABB, secondly, Schneider Electric, thirdly, Siemens, fourthly, Hubbell, and fifthly, GE. If working on a project that has Frank Adams bus duct, it is important to carefully inspect the bus duct and ensure that it is in good condition. It is wise to consider contacting an electrical contractor for assistance. An electrical contractor can help evaluate existing bus duct and recommend the best course of action for the project. When evaluating bus duct for any project, several key factors must be considered to ensure proper functionality, safety, and compliance with electrical codes and standards. Firstly, it is important to determine the current carrying capacity required for the application. This involves calculating the total load in amps that the bus duct will need to handle. The selected bus duct must have an ampacity rating that meets or exceeds this calculated load. Secondly, the voltage rating of the bus duct must match the system voltage. Using a bus duct with an inadequate voltage rating can lead to insulation breakdown and potential electrical hazards. Standard voltage ratings for bus duct systems include 208 volts, 480 volts, and 600 volts. Thirdly, the physical environment in which the bus duct will be installed is crucial. Factors such as temperature, humidity, and the presence of corrosive substances can affect the performance and lifespan of the bus duct. Bus duct enclosures are available in various NEMA ratings to protect against different environmental conditions. Fourthly, the length and configuration of the bus duct run need careful planning. Voltage drop can occur over long distances, so it is important to calculate the expected voltage drop and ensure that it remains within acceptable limits. The bus duct system should be designed to minimize the number of joints and bends, as these can increase resistance and reduce overall efficiency. Fifthly, consider the short-circuit current rating of the bus duct. The bus duct must be able to withstand the maximum fault current that could occur in the system without sustaining damage. The short-circuit current rating should be verified through testing and certification by a recognized testing laboratory. Sixthly, the type of conductor material used in the bus duct affects its performance and cost. Aluminum and copper are the two most common conductor materials. Copper has higher conductivity but is more expensive than aluminum. Aluminum is lighter and more cost-effective but requires larger cross-sectional areas to achieve the same ampacity as copper. Seventhly, the method of connecting the bus duct sections and equipment is critical. Proper connections ensure low resistance and prevent overheating. Bus duct systems typically use bolted connections with specialized hardware designed to maintain consistent pressure and prevent loosening over time. Eighthly, grounding is a vital aspect of bus duct installation. The bus duct system must be properly grounded to provide a low impedance path for fault currents, minimizing the risk of electrical shock and equipment damage. Grounding should comply with local electrical codes and standards. Ninthly, the type of enclosure and its suitability for the environment are important. Enclosures protect the bus duct conductors from physical damage, moisture, dust, and other environmental factors. NEMA ratings indicate the level of protection provided by the enclosure. Tenthly, consider the ease of installation and maintenance of the bus duct system. Modular bus duct systems can simplify installation and allow for future expansion or modification. Regular inspection and maintenance are necessary to ensure the continued safe and reliable operation of the bus duct system. The National Electrical Code, or NEC, provides comprehensive guidelines for the installation and maintenance of bus duct systems. Some relevant NEC sections include Article 368, which covers busways, and Article 310, which deals with conductor ampacity. It is essential to consult the latest edition of the NEC and any applicable local codes to ensure compliance. Furthermore, consider the specific application requirements when selecting bus duct. For example, in data centers, bus duct systems are often used to distribute power to rack-mounted equipment. In industrial plants, bus duct can provide a flexible and reliable power distribution solution for machinery and equipment. In high-rise buildings, bus duct is used to distribute power vertically through the building. When evaluating bus duct manufacturers, look for companies with a proven track record of quality and reliability. Check for certifications from recognized testing laboratories, such as UL or ATL. Ask for references and consider visiting existing installations to see the bus duct in operation. Also, investigate the manufacturer's warranty and support services. A comprehensive warranty can provide peace of mind and protect against potential defects or failures. Technical support can be valuable for troubleshooting and resolving any issues that may arise. When working with existing bus duct systems, it is important to conduct a thorough inspection to identify any potential problems. Look for signs of damage, such as corrosion, cracks, or loose connections. Check the insulation resistance of the conductors to ensure that there are no insulation faults. Measure the voltage and current at various points in the system to verify proper operation. If any problems are found, they should be addressed promptly to prevent further damage or safety hazards. If modifications or repairs are needed, it is essential to use qualified electrical contractors who are experienced in working with bus duct systems. They will have the knowledge and skills to perform the work safely and correctly. Remember that working with electrical equipment can be dangerous, so it is always important to follow proper safety procedures. Wear appropriate personal protective equipment, such as safety glasses and gloves. De-energize the bus duct system before performing any work. Use insulated tools and equipment. And always double-check your work to ensure that everything is properly connected and secured. In addition to the technical aspects of bus duct systems, it is also important to consider the economic factors. The cost of bus duct can vary depending on the size, configuration, and features of the system. It is important to obtain quotes from multiple manufacturers and compare the total cost of ownership, including installation, maintenance, and energy efficiency. A well-designed and properly installed bus duct system can provide a reliable and cost-effective power distribution solution for a wide range of applications. By carefully considering the factors discussed, one can select the right bus duct for the project and ensure its safe and efficient operation. Finally, always keep up to date with the latest advancements in bus duct technology. Manufacturers are constantly developing new and improved products that offer enhanced performance, safety, and efficiency. By staying informed, one can make the best decisions for the project and ensure that the electrical system meets the needs for years to come. For example, some manufacturers now offer intelligent bus duct systems that incorporate sensors and monitoring devices. These systems can provide real-time data on voltage, current, temperature, and other parameters, allowing for proactive maintenance and troubleshooting. Another trend is the use of prefabricated bus duct systems, which can significantly reduce installation time and costs. These systems are manufactured in a controlled factory environment and delivered to the job site, ready for installation. Also, there are now flexible bus duct systems available that can be easily adapted to changing load requirements. These systems use modular components that can be reconfigured as needed. In any electrical system design, remember to incorporate safety factors and redundancy. It is generally recommended to oversize the bus duct capacity by at least 25% to accommodate future load growth. Also, consider providing backup power sources, such as generators or uninterruptible power supplies, to ensure continuous operation in the event of a power outage. Electrical system design is an iterative process that involves careful planning, analysis, and coordination. By working closely with electrical engineers, contractors, and other stakeholders, one can create a safe, reliable, and efficient power distribution system that meets the needs. When specifying bus duct, be sure to include detailed technical specifications in the procurement documents. This will help ensure that the suppliers understand the requirements and can provide accurate quotes. The specifications should include the following information: firstly, the ampacity rating; secondly, the voltage rating; thirdly, the short circuit current rating; fourthly, the conductor material; fifthly, the enclosure type and number rating; sixthly, the connection method; seventhly, the grounding requirements; eighthly, the applicable standards and certifications; and ninthly, the warranty and support services. Also, consider including a requirement for factory testing and inspection of the bus duct before shipment. This will help to identify any potential problems early on and prevent delays in the project schedule. Factory testing can include tests for insulation resistance, continuity, and short circuit withstand. In addition to factory testing, it is also important to perform field testing of the bus duct after installation. Field testing can include visual inspection, torque testing of bolted connections, and infrared scanning to identify hotspots. Infrared scanning can detect loose connections or overloaded conductors, which can lead to overheating and potential failures. Regular maintenance is essential for ensuring the long-term reliability of bus duct systems. Maintenance should include periodic cleaning, inspection of connections, and testing of insulation resistance. A detailed maintenance schedule should be developed and followed. The maintenance schedule should be based on the manufacturer's recommendations and the specific operating conditions. Also, keep accurate records of all maintenance activities, including dates, descriptions of work performed, and any problems encountered. These records can be valuable for troubleshooting and identifying trends. When performing maintenance, always follow proper safety procedures. To energize the bus duct system before performing any work, use insulated tools and equipment. Wear appropriate personal protective equipment, and always double-check your work to ensure that everything is properly connected and secured. If any problems are found during maintenance, they should be addressed promptly to prevent further damage or safety hazards. Minor repairs can often be performed by qualified electrical technicians. However, major repairs or modifications should be performed by experienced electrical contractors. It's vital to keep documentation related to the bus duct system organized and accessible. This documentation should include the manufacturer's drawings, specifications, and installation instructions. It should also include the results of any factory or field testing. Having this documentation readily available can be invaluable for troubleshooting and maintenance. When replacing bus duct, it is important to select a replacement that is compatible with the existing system. This includes matching the ampacity, voltage, and short-circuit current ratings. It also includes ensuring that the physical dimensions and connection methods are compatible. If a compatible replacement cannot be found, it may be necessary to modify the existing system. This can be a complex and costly undertaking, so it is important to carefully evaluate the options before proceeding. Furthermore, environmental considerations are becoming increasingly important in electrical system design. When selecting bus duct, look for products that are energy efficient and environmentally friendly. Some manufacturers now offer bus duct systems that are made from recycled materials. Also, consider the disposal of old bus duct. Many components can be recycled, such as the conductors and enclosures. By recycling old bus duct, one can reduce waste and conserve resources. The design and installation of bus duct systems should always be performed by qualified professionals. Electrical engineers and contractors have the knowledge and experience to ensure that the system is safe, reliable, and efficient. Engaging qualified professionals can help avoid costly mistakes and ensure that the project is successful. When selecting an electrical contractor, check their qualifications and experience. Ask for references and review their past projects. Also, make sure that they are licensed and insured. A reputable electrical contractor will be able to provide a detailed proposal that includes a scope of work, a schedule, and a price. The proposal should also include information on the materials and equipment that will be used.